Okay, so today I'm gonna start um, some difficult question, which is LRU cache. So the reason why I'm saying this is difficult is that the acceptance rate is low, 40%, but it is quite popular. It seems very popular. Ooh, popular questions. Okay, so because it shows very low acceptance rate, which means that this is difficult, and then I will have some hard time. Maybe I cannot solve this within the time, but I have to, speak out loud what I'm thinking in my brain, trying to find out how to solve this while trying to solve this. So that's the point, okay? So let me try to solve. Let's start the timer. Okay, designer data structure that follows the constraint of LRU cache list recent used cache implement LRU cache class LRU cache initialize LRU cache positive size of capacity. Int get returns the value of the key if key exists. So cache is let me refresh my mind. Cache is something like well, do you have this memory address? Then in your cache LRU cache. So this is cache list recently used. So yeah, cache. So it's like a it's like a stack, right? So the rest one will be kept inside the cache, and then the old one, which hasn't been used lately, will be evicted from the cache, right? Void put int key value. Update the value of the key if the key exists. Update. Otherwise, add the key value pair into cache. If the number of the keys exceed capacity from this operation, evict the least recently used key. So which means that we need to keep the time when it is used. This function get and put must run all one average time capacity. So LRU cache put blah blah blah, and then put 2, so size is 2, put 1 2 2, and then get 1, which is used recently, and the 3 2 hasn't been used. Evict key 2, and then get 2 not found. Okay, get 2 not found. Okay, and then put 4 4, so we have now 1 and 3 and but 4, but LRU key was 1, evict key 1, cause LRU key, what's LRU key? LRU key was 2? What's the meaning of the LRU key? Get key, return the value of the key. Anyway, LRU key. So recently used. So put is also considered the case of use, right? I'm not sure what the meaning of the LRU key was. 1. Put 1 1 2. Key was key. Value of the key exists, key, update the value of the key if the key exists, otherwise add the key value into the cache. The number of keys exceed evict the least recently used. Right here for 2 let's think about this one more. So in here we added 1 and then 2 and then we use this one and then put 3 and then we evict 2, right? And then this one is recently used. This one is recently used. And then get 2 minus 1 and then we will enter 4. So we'll evict 1. And then this one is recently used. And then get minus 1, 3, 4. So the key of this question is how to maintain least recently used. So if the capacity is very long, like 10, and then if we use, so do we need some kind of counter? Because some has been used 10 seconds ago, A is used 10 seconds ago, B is full, and then B is used 8 seconds ago, C is used 5 seconds ago, and then we are gonna, and then others are not used at all. And then for the second time, for the 10th time, let's say that there is item 1 from 10, then at time 1 is used, at time 2 is used, and then somehow at time 10 is used, and time 11 we wanna enter something, put something, we have to evict 1 because evict was used 10 seconds ago, right? So and then should be done in this way. So like 1, 2, 3, 4, 5, and then at some time t, let's say that this is used, and at some time t, this is used, and some time t, this is used. Likewise, this is used, this is used. And then we have to put, then we can select this very easily in O over 1. How? So O over n solution is easy because we can keep track of some time. This says O 1. Put also need to be O of 1. So if we don't think about O of 1, if we think O of n, when we put at time 1, 2, 3, 4, 5, yeah. At time 1, what it can do, at time 3, what it can do, at time 1, you can modify the time stamp of this is 1, and this is 2, 3, 4, 5, and now 6. T6, we're going to do put, and then we can go through 6 minus their time frame. So this one is pretty easy, but in case of O1, O1, you need to pick one thing very quickly, so some structure to for such a thing could be hash map O1. Hash map is O1. I was thinking some min heap, but putting something into the min heap takes log n, so min heap is not a candidate. So I think about using hash, some way to using hash, but how do I know that something is the smaller one, something is smaller? They have all value, and then each item you can have some key, you can have some timestamp. O of n, O of 1, average time complexity. O of 1. Wow. Wow. Or maybe you can use Q. So here we can push 1 into Q, push, and then we have to pop Q, right? And then, but if we get 1, then inside the queue, we have to, queue is at the front of the queue, but we now need to know that, let's say, get 2. So inside the queue, it's like 1, 2, 3, 4, 5. Then we will enter 2. but we have to remove this. So Q is, we have to remove this. Otherwise, the Q, if we has a lot of get, then the Q will be very, very big, because it says that this many calls. So how can you eliminate 2 from here? It is kind of difficult. What if, so the range of keys 0, 1, dot, 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 0, 0, 0. What if we create some array vector for this, and then and then 1, 2, 3, 4, 5 index, and then so we'll add time, and then at time 6 we want to get to, we can modify this to 6. This is pretty easy, but the thing is, when we want to put, we have to go through everything to find out this one. This is also O when. So the question is, how can you find the least one? Well, let's think about the push one again, and then wanna push 2. Let's do this, and then we wanna push 6. And then 6 is over the capacity, so we have to evict 1. But let's say that we have excess get before pushing 6, so we have to evict this. But this was in here before, so we cannot evict this. Then we go to here, and then this cannot be, so we can remove this. Well, one way to do this is when we try to put, we can have when you try to push 6, when there's a get, I was thinking that since this is 1, let's say that this is 3. Since this is 3, we'll go through this, then find out 3, then remove, since they are duplicated. They are duplicated. O of n, O of 1. And what else can I think? What else can I think? One. to here, we get 2, or push 2, put 2, get 2. Let's think about get 2. And then let's think about this is some kind of set. Then 2 is in the set. So if we can modify the timeline 6, then we have to get the one with the least value. In that case, we also need, this cannot be done in O(n). I was thinking priority queue. O(1). Can I have 3 minutes to think about this? After 3 minutes, I'll be back. Is that okay? Yeah. This is push. Let's say that this is get. Then we have a map. Then we can get this. And then modify that. This is recent one. And then we can push 3 to the new value, and then we can multiply that. And then we can push 6. If we have a queue, then we know that we have to evict this. Let's say that this was 1, and then this was this. If we have 6, we know that this need to be. This is not the one. 2시간이나 했네. 목소리가 왜 그래? 밥 먹어야지. 어디 먹고 와? 그래? 사람 너무 많아? 그렇구나. 알았어, 빨리 와. 뭐 먹을래? 뭐 라면 물이라도 끓여놓을까?
아니 라면 먹고 싶지 않고 샐러드? 오빠 뭐 먹고 싶은데?
지금 아무 생각 없는데. 샐러드에 라면.
오빠는 라면 먹고 싶구나.
샐러드 반, 라면 반. My wife is coming and I need to prepare lunch, so let me finish this session here. Not sure whether I will continue this or not, but I will think about how to solve this while preparing lunch. Bye.